The data in the table to the right are based on the results of a survey. Click to view the critical values. Okay, which variable is the explanatory and which is the response? So explanatory should be the commuting time and response should be the well-being score, because depending on what the commuting time is, your well-being score responds to it. So explanatory is the commute time and the response is the well-being score, because commute time affects the well-being score. The well-being score does not affect the commute time, but the commute time affects the well-being score. That's why the well-being score is response. Scatter diagrams, so the same business, we can either do it on StatCrunch. So stats, regression, simple linear. First variable is commute time and second variable is well-being score. And you remember, you go to the second screen here to get, so this is the pattern I need to be looking at. Okay, let's see if I can remember it. Oh, it has to be first or the second. So let's see. So at 6, you have 69.3. So this doesn't even seem to have a 6 in it. This one probably does. So it's the second one. Yeah, because this is probably 6 and 69.3, whereas this one doesn't have a 6 along the x. Determine the correlation coefficient. So let's go back to the StatCrunch previous screen. So the correlation coefficient here was negative 0.9847. Negative 0.985. Does a linear relation exist? So we again compare it against the critical value. So we have to see how many points we had. So 1, 2, 3, 4, 5, 6, 7 points. So the critical value is 0.754. So for the first time, our correlation coefficient has exceeded 0.754, the critical value in absolute value. So this time there will be correlation. Yes, and it's negative correlation because the R was negative. Because R is negative and is less than the opposite of the critical value. So that's actually correct, because look, the critical value that we saw was 0.754. The opposite of it is negative 0.754, and the R we have is less than that, because negative 0.985 is less than negative 0.754. So the more negative number is less than the less negative number. So you could either say in terms of absolute values, or you could say like they've said here. An engineer, okay, determine which variable is explanatory and which is response. So weight is explanatory and miles per gallon is response. So depending on what the weight of the vehicle is, that will determine how many miles per gallon it will give you. Explanatory is weight and response is miles per gallon. Scatter plot, I think we are now used to doing it on StatCrunch. Stats, regression, simple linear. First variable is weight, second variable is MPG. To the second screen, so you have a point high up and point like here and here, here, and here. So let's see if we can remember it. Actually, okay. So looks like choice D to me. A point higher up, then you go a bit down, and then 2 points at almost the same level, and then you go down. And the correlation coefficient was also there. Back to the previous screen. So it was negative 0.946. Because the correlation coefficient is negative, and the absolute value of the correlation coefficient is the positive value of that, so it'd be 0.946. And now let's see how it compares to the critical value. Now, okay, for the first, okay, I thought they don't give the critical table, but they do. So we had 1, 2, 3, 4, 5 points. So in this case, the critical value is 0.878. Goes here. And this is greater than, right? The absolute value of our correlation coefficient is 0.946. That's greater than the critical value. So there is, and there's negative because remember the correlation coefficient was negative. Okay. So that finishes this section.